Welcome back to the bench, everyone. Hope you're having a great weekend thus far. I am actually about to start yet another project. I mean, obviously, I need more, right? Well, to better understand that, we need to go into the storage area for all of my radios, and, you'll see what I mean. Oh, where do we begin with this mess? Well, for one thing, for folks that were watching my video on the exit light previously, here it is, currently in day 2 of being left on, and I think we're getting close. We're already over 24 hours. I think it has gotten a little bit dimmer, so the battery is starting to go down in terms of the output voltage. So might get a total of 36 hours out of it, but it'll probably be pretty dim by then, because when I did that calculation, I did not account for the fact that batteries do not just maintain their voltage and then die. It slowly tapers off as the cell drains. So that was a bit of an oopsie. But that's not why we're here. We're actually here because of this. And it's a little bit of a mess. What? Not you. Oop, that's still in shot, isn't it? So this, as ugly as it looks, is a Remmler Model 44. Really. But this was at my grandmother's house for quite a while. I fixed it up for her a few years ago. Works wonderfully even on 4 inches of antenna, super smooth dialing. The problem was the front of the radio here. I can actually show it, just a panel that drops in. The original front of this set was completely delaminating. The veneer was coming apart, and the veneer that crusts over the top of this section here had split away in the center, and it just looked all kinds of awful. And that's not to mention the fact that this must have been in someone's garage, because there's red spray paint in a number of places on the cabinet. So I decided, you know what, I'm gonna try and do my best to redo the cabinet. First thing I had to do is strip the veneer off the front, and I started making a replacement plywood substrate for the front here, trace the pattern off the original, and I've got to finish doing that. And then I'll wind up putting new veneer over the front and then completely refinishing it. However, during that period, that means my grandmother doesn't have a radio, and she enjoys listening to NPR and any other local stations that are around. And, well, honestly, I wanted to get her another set as a loaner for the meantime. Now, as it's pretty obvious, I have a few sets, just a few. And I thought, well, maybe this Philco. It's a nice little table set. Cabinet's already in fine shape, all the knobs are there, just need some chassis work. That would work okay. I didn't have a whole lot of sets that were already in decent enough physical condition that I would be fine with just dropping off with her. So I talked to her about it, and she actually came back and said, well, if I could get something that's maybe a little more like furniture, that would be fine. And I thought, oh, a console. Well, absolutely. I happen to have just the one. This little guy right here. This I picked up in college for, I don't know, $40? Somewhere, maybe closer to 60. I picked it up because it was in very nice condition. The lighting in here is terrible. My chandelier does not provide enough light for this. But this is a Colonial. Now, I didn't recognize the brand at the time. Colonial is actually better known for being a contractor and supplier of radio chassis for Sears and Roebuck for their, what was their line called? Either way. So Sears, much like Montgomery Ward's radios, were built by third parties, and then Sears and Montgomery Ward's and whoever just put their name on them. Pretty typical practice. Colonial was one of the suppliers for Sears, and this is actually a pretty neat little set. Now, there is one thing wrong with this cabinet. It is original finish, but these two knobs here are supposed to have medallions behind them, thin stamped brass, I believe. And as you can see, the rest of these have a 2, 3, 5, 6. Yeah, these are octagonal knobs. These knobs are actually the same, as far as I can tell, as some early 30s Sears sets. And the name for those is just utterly Silvertone. There we go. So some Silvertone radios had the same knobs here, and I haven't checked, but there's always the possibility that the chassis that's in this may have been used in a Silvertone set. Either way, these two knobs here are replacements, and there's just the faintest hint of glue behind them from where the medallions used to be. And the few photos I've seen of this set show that they were supposed to be there, and I think one probably said volume, and one probably said something like, that feels like a band switch. That or its tone. It's got a lot of positions, so that might not be a band switch. Yes, what do you need? Either way, this was the only set that I have that fit the size requirements that she had and was in good enough physical condition. I'm just going to clean it and wax it, and it should be good enough. However, that means we need to go inside and deal with the chassis because I have not worked on it. And again, it's one of those things you drop it in the collection and forget about it. So we're going to stop forgetting about it and drag it into the basement and see what we can do with it. Okay, so I got the chassis extracted from the cabinet, and I realized when I started off that I didn't actually mention what model of Colonial this is. I had to do a quick search on Radio Museum to verify. This is a Colonial Model 604 from about 1933, 1934-ish, based on their entry, which is about right given that it's pre-octal, and it uses the newer style ST tubes with the... Well, they're using a mix of some older and some newer tubes in here. I mean, the 76 that's in here is still an older 5-pin base, and it uses an 80 rectifier. It's got push-pull 47s, and then everything else is, what did it say? We got a 6A7, 278s, 75, and a 37. 75? I thought for sure this was a 76. Is that wrong? It's a 76. Interesting. Either way, it's pretty nicely laid out little set. It is interesting, at least to me, on the dial here. This assembly is not rigidly mounted. Instead, there are two springs. One down here that goes along the tuning shaft, and then another directly over the shaft coming out of the tuning condenser. And if you look over the top of it, you can see there's a nut holding this disc in place with a set screw, and then there's a spring sticking out of it, and that presses on the dial here. I'm not entirely sure why that is. The only thing I can think of is that when you put the chassis into the cabinet, this spring loading here basically ensures that if you shove it in too far, you don't crush the dial against the glass in the escutcheon or something. Maybe it's just to ensure that this will be nicely positioned regardless if the chassis itself is slightly cockeyed or something. Now I do need to pull a schematic for it. I don't have one pulled up at the moment, so I'll double check Radio Museum here. One thing that was curious to me was that it has 3 leads coming out of the side here, and the sticker on the back does actually point out their colors. I'm pretty sure this is for antenna connections, but they each have little fawn stock clips soldered to them. And let me flip the chassis around and we'll take a look and see what the sticker on the back lists them as. Now I have been doing a little bit of chassis detailing because this was pretty nasty when I got it, and I only did a light dusting of it when I first picked it up while I was in college. It's kind of just been in storage since then. Got some odorless mineral spirits and got a lot of the gunk. There's a lot of tobacco residue on this thing, like every square inch of it, and there's a whole bunch of stuff in there under the tuning condenser. It's all gross. But if we lean this up here, and this chassis does have a steel bottom plate, which is kind of nifty. When we bring that in, we can just barely see down here we have a black, a red, and a green lead. And I'm not exactly sure why there are three. Maybe they were going to be setting up for a loop antenna? I don't really know. Unfortunately, what really sucks is the upper section here. Oh, there's the bare remnants of the model number 604. This right here would have had the control layout. So it says that the far right switch is for on-off and sensitivity control. Or no, sensitivity control. There's one that just says switch. Oh no. Sensitivity control is far over that. The next one below it is on-off and presumably volume. Either way. Chassis is in pretty nice shape, despite the gack that's on it. The tuning condenser is sitting on 4 rubber feet, which are totally toast, which means I'll probably have to dig that whole unit out of there, which I should anyway, because I want to be able to clean in and around it. We've got 2 electrolytics coming out of the top, a 16 and an 8. This one has been replaced as a paper label, and I believe it says 8 microfarads. What is that? Yeah, I believe it says 8, and then this little guy right here is labeled as a 16. So we've got those to deal with. Now, one other odd thing I noticed about the dial is that the dial lamps hang off the end of the tuning condenser here. However, this disc right here that's just behind it seems to be some sort of diffuser, or was meant to be. And I do remember when I did power it up and put a light source back there, it had a reddish tint to it, and I'm not sure if that's because this is actually wearing out or what. Now, do I have a small enough screwdriver to try and get in there and undo that set screw? Not that one. Hang on a second. There we are. Oh. Okay, that's important. That's going to be how we set the dial to the tuning condenser. So we'll have to... I'll have to fix the tracking. But that does keep the more important parts out of the way. And where am I going to put this? Okay. Let's go over here for now. So yeah, there's this disc right here, and that should wiggle right off the end, right? Oh wait, no. No, it's retained, because that is how we're tuning it. This outer rim here is a friction fit to this shaft. And I don't know how the shaft is retained. I'm going to guess originally when the rubber on the tuning condenser wasn't fried, it would have had a... Ooh. Okay, it just cracked right there. So we're going to leave that alone, because I'm just making everything worse. Thank God this isn't somebody else's. Okay, well in the meantime, I'm going to pull the tubes off the back, get it flipped over, and we're going to take a look inside. I have been in here once, but I didn't do any work to it. I seem to remember that the wiring on the power transformer seemed a little sketchy. Maybe because the insulation wasn't all that great. Okay, so it's got some indentations here, so I should just have to pry up on that just a little bit. Ooh, yikes. Black Beauties. I don't remember that. Okay. Oh man, and that band switch. Is there anything really important tucked in there that I'm going to have to fight to get out? Doesn't look like it. How's that? You guys too far away? I think you're too far away. I'll drop you down a little more. Okay, what are we dealing with? So that's new. These are going to be obnoxious. They're in the way. Sockets are nice and large. We've got a lot of dog bone resistors. I'll have to go around and check and see how those are. Wax caps. We've had some Sangamos put in here at one point. Sprigs. Nothing on the volume control appears to have been messed with. Man, I wonder what that was. That is pretty crispy looking. These are definitely new, and they are leaking oil. That's pretty gnarly. There's our power cord. That's going to be going away. And I can see right here, this capacitor, which is tied to ground, this is one of our line safety caps. So that's going to have to get replaced with a Y-type. And our two electrolytics are mounted here, and they're screw type, which means I can unthread them, pop them out, and then clean that area of the chassis. However, one thing I am seeing here that's not so great, maybe it's only on one of them. I'm looking at the wiring for the tuning condenser, and it looks like, sorry I'm moving you around so much, these large yellow wires here coming up from the tuning condenser tub, but the mounting points, there are 4 of them, one hidden down here. This one right here is partially hidden under a ground lug. I thought it was being used as the ground lug. Well, maybe. Yeah, it kind of looks like it is. I mean, that makes sense. You'd want the tub to be grounded. So that's not super. Moving all of those components would certainly not be easy. And right now, these sprigs are being grounded to at. I could certainly find a different ground to move them to that's not quite so in the way. I can also see this guy right here. This is a flexible resistor. It's actually got some little tiny coils. They're capped off at either end. These, I've seen the advertisements for these. You could buy them in several inch lengths, and then you simply trim them down and measure until you get the resistance you want, and then put the little spring wire ends on, and there you go. You have your own custom-made to suit resistor, and I believe these are intended for power resistor applications. Kind of crazy. I replaced one of those in that Atwater Kent table set a little while ago. The rest of the wiring in the set doesn't look so bad. This is all the woven style cloth covering, so it doesn't harden up and crack off or anything, which is good. But the power transformer wiring, especially in here, I'm not sure if these capacitors here have been leaking onto them or what, but it looks, wow, it is really messy. Also, the positive connection from this electrolytic is coming off and just going to this large nightmarish blob right here. This, yeah, and this replacement resistor with the 1000 ohms on the outside, this is some hack job work. That's, oh, here. You're too far away now. So, get you in there just above the power transformer. So what I'm looking at is we have electrolytic here, an electrolytic there, and got friction tape going to the power transformer there. That's probably for the power switch, right? Where's the power switch? That's not it. That's also not it. Okay, so that's probably the primary winding switch connection there. Yeah, because this is the other end of the power. That resistor is coming off of this point here, going up to the old connection. So it looks like both of these capacitors have been replaced. This one actually has a giant serrated inside lock washer. And then we've got some more marvelous tape work here. And wow. I really should have picked something different for this. I had to go for the one radio in the collection that's just kind of miserable on the inside already. But I was going to wind up working on it at some point anyway. So I need to pull a schematic and double check what the power supply wiring looks like, because this has an electrodynamic loudspeaker like most other sets of its period. Got the socket for the speaker over here. It is a 5-pin. And dollars to donuts, they're going to be using the field winding as a power supply choke in between the two electrolytics. So the wiring for that should come back around, head over to these in some fashion, and I want to verify all of that. Also looks like we only have one line bypass capacitor here attached to the power transformer. That's okay. But yeah, the condition, these are the power supply leads right here, and they are very sticky, and I guess they do kind of have insulation on them, although these ones right here don't have a lot of insulation. Yeah, it's a little iffy, but not impossible. Just takes time, and it's going to take time to replace some of the ones that are tucked up in here. Man, that is diabolical, because these are riveted in place. This deal here must have been put in as one sub-assembly, put together and then dropped in place. Man. Alright, well, I'm going to stop talking and go check the internet real quick, and I will be right back. Okay, so I pulled out my... This is supposed to be the 5th edition of Riders. Unfortunately, I don't have the full volumes 1 through 4. Instead, I have this book, which is 1 through 4, or 1 through 5, abridged. This schematic was supposed to appear in volume 5. Well, here it is. And our power supply section down here, we've got a single, it looks like a .003 microfarad cap on the line. And then we've got a 2.5 volt circuit here with a resistor in the center tap. Okay. So our filament connection there with the dial amps across it, but more importantly, rectifier. There's our speaker field, 1100 ohms. And there is a 15 ohm half watt. I want to make that a little bigger. Resistor from the field over to here, and that looks like that's going to be our bias supply connection. It's going to the grid, so yeah, so that's where we're getting bias from. So we have what appears to be a 14 microfarad at 500 volts coming directly off the cathode of the 80, and... Really? What are they doing here? So they've got that... I am marginally confused here. Normally, the cathode is the most positive connection in the power supply, and they use the center tap here as the most negative point. But from the way I can see them wiring these capacitors, they either put the labels in backwards. Odd. So where is this going? Okay, so the 6A7 is the oscillator and mixer. We have a RF amplification stage. It is supposed to have a 75 and not a 76. As the detector tube, as well as the AVC diode. Okay, so I have a ton of those tubes kicking around, so it'd be easy to drop one in there. 37 phase changer. What? This is for a model 604. Oh, wait a minute. 2, 3, 4, 5, 6, 7, 8. Oh, I know what the problem is. There's supposed to be a 37 on the outside. The 76 and 37 are both triodes. should be close enough to each other that you can swap them out directly. That's probably why. The 75 is going to be one of the ones under a shield, and it's going to have a grid cap connection on it. Okay, so this, yeah, that's why. That's supposed to be a 37. I have some 37s. I could put one of those in there. But we need to figure out, check for the 80 rectifier, see where the connections are going to on those capacitors, because I am genuinely curious. And I will get back with you in a moment after I've done a little bit of analysis of this area in the chassis. Okay, I felt it necessary to pop back in and talk about a few things I have been dealing with on this. First and foremost, this schematic is terrible. Just in terms of the resolution of it, I have looked. This is the only schematic that appears to have ever been printed for this thing. The writer's copy is the only one you're going to find on the internet, unless you get really lucky and maybe... anyway, this is direct from Colonial themselves, and writers just republished it. The problem is a lot of the component values on here are very poorly legible. So 5s and 6s might blur together a little bit. On the whole, it's not bad. Another problem, like for example these coils here, there are references in the back to, oh, these are the oscillator, the trimmer, whatever. You can see the multi-section switch and all that stuff, and then the chassis got all of its designations. These are all labeled here. They are not in any way, shape, or form labeled up here. We know that this is the oscillator section. We know this up here is the mixer section, and we know this crap up here is the antenna coil section. But which one is which? There's no indication to show which one are in the cans on the top of the chassis, which ones are actually under the chassis and poking up. So that's a bit of a grievance. The other issue I have is there appear to be missing lines or symbols in at least one or two places, and the one that really threw me off was down here in the mixer section. I don't know how close I can get this. But while I was tracing out some of the components on there, I was looking at the two Black Beauty caps that were in place. They're both 0.1s, and I was moving some parts around to try and make space to work on other... just figure out where the heck everything is. So as I was replacing capacitors and some out-of-tolerance resistors in the area, I was tracing through and trying to figure out where those 0.1s came into play. Eventually, I traced down from the circuit here. I started up at the 47s at the output tubes, checked the pinouts online, checked where the control grids went to. So both these tubes share a connection here that goes from, I think that's the suppressor grid. These two are attached together, and it goes over to B+. And that also powers the center tap of the transformer, or the audio output transformer, and that connects to the plate of each tube to run it and push, pull, whatever. So I was running off of this connection here, following it down, came over, okay, there's a 75,000 ohm resistor here, that one's gone high, so I replaced it. Replaced the 0.02. There was a plastic Sangamo cap there, replaced that. And I swapped out this 500,000 ohm resistor here that goes to ground because it had drifted high as well. That was all well and good. But then I went south from the 75,000 ohm to a resistor that I couldn't quite make heads or tails of, and it was... not that one. Yeah, it was this one here. It was a little crusty, and from what I could see, it was either red or orange with a black end and either a yellow or orange dot. It's kind of nasty. So my odds were either 30 or 20,000 ohms, and there are both 20 and 30,000 ohm resistors on the schematic. And both connected together in a similar location, so it was kind of 50-50 what it was going to be. I pulled it out, and this one measured 20. I thought, well, it looks too much like a 30, so I'll keep that in mind. And then throw it on the floor. Well, there's a 30. If we come off the B+ connection past the 75,000 ohm resistor, there's a 30 right here. It's a 1 watt. Well, that one I already know what it is, and I completely forgot about that while I was swapping out a different resistor and had to go back and fix it. That's the big one that connects off the... that's tying together the two replacement electrolytics that are in there. It's floating in space with a great big ball of solder attached to it. So we know where that one is. But then, if we come off from this branch circuit here and we follow it down, mind frame, come on. If we follow it down, past the primary and then come into here. Right here we have a 20,000 ohm half watt resistor, and one end of it is connected to a 0.1, or we would assume a 0.1, but the decimal is very, very tiny. There are no 1 microfarad caps in this. I checked the parts list. There are 0.1s. So obviously that's got to be one of the Black Beauties, because there is that red capacitor was red and was 20,000 ohms, and it was connected on one end to a 0.1 Black Beauty capacitor. My problem with that was that the other end of that Black Beauty was connected to the nearest ground. That would be all well and good, except that nowhere in this spaghetti mess here could I find a direct connection from this node to a ground. You've got some multi-selector switches that have a ground there, sure. There's a 0.05 and a 0.003 in here that tie together, but go into a different capacitor in different parts of the circuit. Those have been replaced. I'll show you in a minute. But ultimately, I could not find a ground. I thought, well, did they just miswire it? And I kept looking, and then I realized, well, okay, if I go up from this joint, it's a common connection between all of these coils, it seems like. Okay. And then I noticed this node right about here. And it's a little hard to see because my screwdriver blade is in the way. But we have this switch. We have that node. There's a 0.1 capacitor on this side, which I have not identified yet. I'm still looking for it. But this node goes down a fraction of an inch on a black line and then stops. There's nothing below it. The line is just missing. Confusingly, the switch down here, the far left contact, does not have anything hooked up to it. So naturally, I assumed, okay, that line there must have connected to that, and they left it out, right? Well, no, except that this switch has a ground attached to the other end of it, and that ground would selectively ground out one of these coils, presumably to shut it off, as far as I can tell. If I was to follow the path from that ground through the switch, through any one of these coils, it comes back out at this node. It makes no sense for one of these coils to loop through from the switch around and then back to the switch. And I realized, after looking at the other coils and all the other capacitors, I already replaced this one, and I already replaced this one, and both of these share one common connection, which happens to be a ground, and those were original caps. They didn't have their connections moved, which means this stub line right here should have a ground symbol attached to it, and it doesn't. So that is where my confusion came from. This 0.1 right here does in fact go to ground through all of this mess over to here. So that should have a ground, and I know it's kind of blasphemous, but where's my pencil? I'm going to rectify that right now because that is driving me nuts. There, that's a good enough ground. So that is what that is missing. There's supposed to be a ground there, and that was just irking me. Anyway, book out of the way, take a look and see what I have done thus far. Okay. Got it propped up on something else because I discovered I was touching the dial to the table surface, and that was no good. Oh, and guess that power cord is in the way. So here's the area in question that I was working on. I've already got one of the Black Beauties out. This guy right here is the 0.1 that was throwing me off. One end of it here is attached back to a 20,000 ohm resistor. This was 22. That connects back to a whole bunch of other nonsense. This is the shared connection that goes to all the coils that are part of the wafer switch, and on and on and on. And this terminal strip happens to have a center ground lug, which I'm going to be making use of to stop whoring off of this ground braid right here that I already need to get access to if I ever want to have a chance of replacing those condenser shock mounts. I'm still hoping it won't be a pain in the butt to disconnect all that, and if it is, I may leave them alone because they're not dry rotted and falling apart yet, and I don't want to take the whole thing apart and then not really be able to get it all back together. Either way. So I figured that out. This guy right here, the orange, obviously orange body with a black end and an orange dot, which is hard to see because the body is also orange. That is our 30,000 ohm resistor, 1 watt, that comes off of B+, and the other end of it actually goes... Hang on a second, I was just looking at this. It goes to a number of places. One of them is this wire here, which runs all the way back to this electrolytic, which is supposed to be a replacement for a 4 microfarad. They used an 8. I will put a 4 in there because I believe I have some. So that all checks out. Needless to say, I don't like this haphazard floating in space whatnot that's sort of tying all the electrolytics together. The issue I'm having right now is figuring out where to put the electrolytics because there aren't any free terminal strips. And I would really rather just put in a new terminal strip to start with and mount them all to it and just flush cut the wires off the bottom of these electrolytics as they are just disastrous. But I need to find a ground point for this point 1, and I want to verify in the schematic where it goes. And this guy right here, which is listed as 1,000 ohms, does not quite jive with the schematic. Oh, actually, no, wait. It may. That's 1,000 ohms. And it is attached to... Oh, some of the coils right here that go to the plate of the 6A7? No, that's not quite right. Oh, but it does actually connect over to another point 1, and that ties into... Okay, that's what this is for. This point 1 right here, which joins at this point right there. Let me show you here. Since that middle row is the mixer section of things, which is all of this junk, these are all these coils have a shared connection right here that comes down to this 0.1 microfarad capacitor, and that comes over here to this 1,000 ohm resistor, which in turn ties back to B+, which is what this Black Beauty, that's our 0.1, and this replacement 1,000 is our 1,000 coming off of B+, with yet another splice together connection. That's going to go away, that's going to go away, and this shit's all going to go away. It's just in the way. When I do these, I like to move as many things out of the way as I possibly can. So for over here, I clipped one end of the Black Beauty, the ground connection, to move it out of the way, and then just start working in an area to clean it up and reduce the amount of clutter, so that when I have to go back in and deal with something a little more difficult like figuring out the power supply, I have a lot more real estate to work with. But the next thing I'm going to work on, instead of the power supply though, is I'm going to finish off this little corner right here with the audio section. I need to replace this 0.05, which is a correct value, with this Sangamo cap, and get that out of there. I double-checked the values on some of these, and I think they've drifted a bit, and I'm just going to go ahead and replace all of those with new ones. Yeah, you could make new dog bones. I've seen people make them and paint them and all that junk, but I'm not taking the time to stuff any of these caps. There's nothing left to stuff in some of those cases, so they're just going to get outright replaced with appropriate or higher wattage resistors. Now, the safety cap that I have, I did a little digging, and I have one that is close to 0.003. This one, yeah, it's a 0.002, or 22. And what's nice is that the end of this right here, the ground is over on there. The leads of this little guy are just not long enough to make that, but the terminal strip it's attached to already has a ground right here, so we'll be able to place it on those two lugs, no problem. I'm also not sure if I want to go through the trouble of giving this a new cloth cord. Normally on sets that had cloth cords like this, especially my 1920 sets, I do like to put new cloth cords on there. But in this one's case, I don't have any additional wire laying around, or at least not enough of it. And I may just drop a new brown zip cord in place, because this is... Yeah, I think I'll just put a new zip cord in there to make things easy, and because when I do one of these junction points, I want everything on that junction point to be done. I don't want to solder one thing in and then have to go back and solder 3 or 4 other things in later. I want to get everything to that one point cleaned up, which is why the other end of this resistor is not soldered in place, because I'm going to replace this resistor right here. Anyway, that was long and boring. I'm going to get on to replacing some more of these caps, and I'll be back in a bit. Okay, so I have done quite a bit of cleanup work in here. Please excuse that red wire nut, that's a temporary measure at the moment. But I have pretty well cleaned up everything in this corner of the chassis, and pretty much everything to do with the power supply. There is still one small electrolytic over here in the corner. This guy, which is supposed to be a 4 microfarad 300 volt unit. Haven't replaced that yet. I will clip a replacement in temporarily, because it's paper, I don't trust it. But to do a quick recap of what I wound up doing to make this better, it's still kind of a mess. There's a lot of stuff crammed in this area. I replaced both of those Black Beauty caps. They were leaking pretty badly, left some stains on my table. In order to do the electrolytics, let's see, it should appear over here and behind one of these power cord wires, so let me move that over. We have a vertically mounted terminal strip. I decided to put a hole, a number 6 hole, in between these two electrolytics so that it's not visible from the outside, and I also dug through my parts bins and found a screw that matches all the rest of the ones used, because a lot of the terminal strips underneath here are also either attached with rivets or with slotted head screws. So aesthetically it matches. So I've got that held down. This one just happened to have 4 terminal tabs, which is fantastic. I have a 16 and a 10 microfarad to replace the 14 and 8 microfarad caps respectively. Good Nishikon brand ones. It's what I try to buy nowadays. And I have tried reusing as much of the original wire as possible, like the positive lead coming off the 80s cathode here is going to this center pair of bars, which goes to the positive on each of the electrolytics. The negative on the second cap, the 8 microfarad, originally went to ground, so I have a ground connection. And this happened to be a convenient point to put one of these 0.1 caps over, as well as a new 1000 ohm resistor that happened to be there. There was a ground over here that I could have used, but it's being shared by a number of connections from the tuning condenser tub, and I want to be able to remove those in the future so I can get under there and replace the mounts. So I avoided using this, and this guy right here I moved over one position so that I would have access in the future to take these 2 wires off, and then I believe there are only these 3 big yellow connections from the tuning gang to allow the whole thing to drop down. I'm hoping anyway. Completely flush cut the connections from the old electrolytics to get them out of the way. Those are very obviously replacements. In fact, yeah, you can see the hole is actually a little bigger than the electrolytic that are put in there. Let's see, what else? This is a replacement for the 30 ohm 1 watt resistor that was in there. It did measure within spec, but I went through all the trouble to go through and swap out all these other off-tolerance dog bones, and I figured if I'm going to do that, I might as well just get all of them up to date, just to do it. I'm in here, I'm cleaning it all up. The leads on these are kind of short though, and to make sure nothing was floating in space, I heat shrunk all of these, and it's connected back to where it was originally. The one thing I did have to replace that I did not intend on is this guy. This is a 5 watt wire wound ceramic body resistor that is replacing the electrically conductive slinky here that I noticed while working on something else had actually come apart on one end. The insulation was failing pretty badly, and this thing is very... yeah, the tubing is just brittle as hell. So this is garbage. Schematic listed at about 225 ohms and about 3 watts, so 220 at 5 is the nearest standard value. The one thing I have not replaced over here, though, is this little guy. This is a flexible resistor. I believe this is supposed to be 15 ohms. and at least 1 watt. This is part of the speaker circuit. I moved the schematic so I don't have it right next to me, but I know it's part of the power supply, possibly part of the bias supply, but it's still intact and I'm going to leave it alone for right now. What I want to do at the moment, though, I haven't recapped the rest of the set, and it's partially because most of the caps in here are 0.1s, and I used up my last 2 right there. Or I used up my last 3, actually, so I gotta buy more of those. I still have some stuff around the volume and tone control. This one in particular, behind the red wire nut here, I don't know how well that shows up on camera. This nasty black mass right here. I wasn't sure what to make of this at first, and the more I looked at it, I realized this was a paper cap at one point, and it is... I'm not sure if this is a failure or if the outside just got obliterated, because there is another capacitor attached to... Hang on a second, what's the label say this is? I can't tell because that part of the label is destroyed. Might be the sensitivity control. There's a cap attached to the cross of that, the top of that, and it has suffered the same fate. It looks like whatever was on the outside of it just deteriorated something fierce. And a lot of the caps that are in here, especially ones further up in the chassis here, like this guy and that one right there, after looking at them and the solder work, I realized these are all replacements. So this was probably worked on sometime in the 50s? Especially judging from these electrolytics, I'm going to have to guess 50s. Some of these, from the way they've been attached and the appearance of the solder, are most likely original, possibly. The postage stamps are. They still have the original cambric tubing on them for protection. And the ones back here on this control pot, pretty sure those are original, especially the labeling. And the safety cap that was in here was a paper type, and it matches the aesthetics of the others. So I'm safe in my assumption that, or at least assured in my assumption that those were original. But next thing I want to do is get my meter on the B+ rail of this. I have the speaker hooked up over here, and I've got my variac pulled out, which is why I have this wire nut on here. One thing I am going to do before I finish this whole thing up and clean it up is I want to put an inline fuse in the hot side of things. I'm going to use one of those. I've used it on Raw Radio before. It's an automotive style push, and you can take it apart. And it takes a standard 3AG cartridge type fuse. I would use an external fuse holder or even the chassis mount type, but there's not a whole lot of good places to... I don't want to bore a whole bunch more holes. I absolutely could. I could probably put one on the side of the chassis here, and, well, maybe I'll do that. I'll consider it. I don't want to bore any more holes if I absolutely have to. And if I do that, then I have to run a wire from a post over here all the way across the top of the power transformer and blah, blah, blah. It wind up having to run some additional connections. That's a possibility. Either way, I want to fuse it for safety and because it's going to a relative. And it's one of those things where if I'm listening to it, I'll know if it's failed. But if someone else leaves the room and they're not sure what to look for and it fails, well, they might not turn it off in time and maybe cause some damage to the power transformer or who knows what else. So just an added layer of protection. I'll throw one of those in. But for now, I'm going to get this plugged in, and we're going to get meter hooked up. Our B+ positive is this, either of these two legs on the capacitors here, and our ground. I'm going to be using this one over here on the opposite end of the 5-watt resistor. Hopefully that should give us something. And I have actually attached a pair of dial lamps to this thing, so I'll put the meter in range and I'll bring you back here to watch for smoke, because that's mostly what I'm looking for. And the on-off control is a little odd in that the potentiometer it's attached to has about half travel before I actually get to the switch. I'm not sure if it's because it's broken or I don't know. But we're gonna... Actually, you know what? Hang on a second. One thing I do like to do before I get crazy with it is I want to check and make sure that the switch is actually doing its job and that we see continuity across the primary and then no continuity when the switch is off. Well, let me change this back to 200 ohms. Right, we're reading 13.2 across. Let me put the switch back and we read infinite. And back again. Well, okay, so the switch is doing something. A little unusual, but we'll say sure, yeah. That seems to be working okay. I will say I don't much care for their placement of the hot and neutral connections. The binding post they're using here is conveniently located between a chassis ground and a resistor that comes off the B plus section. I have this wired up currently that this is the hot connection going through to the switch and the neutral is going over there back to the power transformer. It's not my favorite either way. Okay, we are high enough. Get the variac on. This guy is on. Again, is that volume? Isn't it volume? Who knows? We will bring this up 10 volts at a time. And I guess I lied about... Oh, you know what? It's not going to do anything because I pulled half the tubes out. It has no rectifier, and... well, we'll bring it up anyway just to make sure that we have something coming off for the tube filaments. Oh. Dial lamps are coming up. Okay. So we do have a power transformer that works. Let me retrieve... well, basically everything that is missing. So there's our... oh, that's not it. Rectifier. It's a little... okay, dial lamps are still low, so we'll bring this up to 30. Got a little brighter. I'm not expecting a whole lot here, but it would be kind of nice to at least hear some static and also to see if we have any B+. Well, the 80 does appear to be getting warm at the very least. Let me turn off some of the lights here. I want to see if I have any filament glow. Definitely have the dial lamps going. Okay, yes, the filaments on the 80 are coming up. Looks like. So that's good. We still don't have anything. That's mildly concerning. I don't think I missed anything. I'm quite positive I got all the connections worked out. I think we've got something shorting out the B+ line, and we're it's not working out quite right. How warm is this guy? Cold. Okay. Well, if there was a lot of B+ dry, we would expect to see something. Well, one thing we need to verify then is if we have an appropriate amount of secondary or plate voltage on the rectifier, because if we have no plate voltage, we are going nowhere in a hurry. Now on this one, plate's going to be the two smaller pins, this guy right here, and a little tricky to get this, that guy right there. Okay. And I don't like bringing these back up right after I've just warmed it up, but we will see what we get. I don't know. That's showing we've got plate voltage. Okay. So not a problem there. We obviously have filament voltage, but let's see. Let's check from here. I was checking directly off of the cathode effectively. We find a different ground. Maybe we just have a bad perspective. All right. Okay, so something's not very right in B+ land. Next thing I'm going to check with that unhooked. I'm going to check this directly to one of these. Yeah, basically nothing. Next thing I want to see is how much resistance do we have from B+ to ground? So here's our nearest ground. Here is our positive rail. Oh, 0 mega ohms. We are reading about 220 ohms to chassis ground somewhere. That's not great. So yes, we are losing all of our B+ somewhere. Now the first thing I'm going to do, because I didn't do it before I powered up like I said I would, and I'm pretty sure that connects to chassis ground, is we're going to do this, and clip this bastard out of here. No change? Okay, so it wasn't that electrolytic. Time to pull out the schematic and see what the hell's going on. So where else does that wiring lead back to? Leads to there, which leads into... Which leads into here. Wait, what the hell? You see that? When I nudge this wire right here, my meter jumps. Okay, we've got a short, it would seem, right here on this wire. What is going on with that? Something about this connection. Did we wind up going through some insulation by accident? We may have. I soldered pretty heavily on this one terminal right here, so I'm going to nudge this gently over. So I think what happened is whatever insulation they were using for what I think are the filament connections is just way too close to this connection here, which I believe is the plate on this tube. I think it's the plate. Okay, so now we are reading near infinite. Yeah, we're reading well past the 20 mega ohm range. But I want to know what exactly is causing that, because that's not something I would like to make a habit of. That is a very stiff connection. So that is one of the filament windings. I'm trying to get it away from there as best I can. It is being very obstinate about it. Okay, so it's saying like 6 mega ohms now. My hope is that I didn't accidentally damage the filament string by having effectively B+ shorting over to that. However, according to the schematic, what are they doing? Well, the pilot lights are on the filament string, and since the pilot lights didn't go out for any reason, it's pretty safe to assume that we didn't overload the filament string and fry anything. So that's good. But yes, it looks like the insulation on this filament connection here is damaged pretty badly. And its proximity to the plate connection is very, very close. Oh, man, I don't really have any good way of resleeving that. It's coming right off the transformer. Well, for the while being, since we don't have a short there now, I would at least like to try firing this up again. Thank you for being patient. So we're going to take that back off of that, set it back to voltage. And we're going to turn this back on and see if we've got anything. Pilot lights are coming back up. We're going to stop at about 50 volts. Oh, that's interesting. We're starting off negative. Oh, for Christ's sake, because I put the leads on backwards. Okay, that's just me being stupid. Hang on a second. There we go. Okay, so yes, we are getting something now. Not a lot, I would say. 20 volts is nothing to really call home over. I'm not seeing anything catching on fire yet, so I think we're okay to proceed. Right. Normally I'm used to it really picking up speed as the rectifier warms up and all the other tubes get up to temperature. Maybe they just aren't. There's a possibility. Well, damn. It's really not what I was hoping for. But it's not completely recapped, so we can't quite say anything yet. There's also still that flexible resistor in here that that's 15 ohms to ground from the negative. That's mostly just bias junk. I'm probably just going to have to go through and do some more capacitor replacement, because honestly, at this point, there's nothing else that I can think of. I mean, the B plus does seem to be functioning at the very least. One thing we... Okay, had a minor malfunction, SD card filled up, and didn't realize that. And now, of course, having left it overnight plugged in, it only has 30% battery for some reason, so try and get through this as fast as I can. I made a bit of an oopsie when I was measuring the B plus earlier. I was measuring it direct to ground. Because of how the B plus circuit is set up with this, that's not really the most accurate place to measure it. In this case, I'm measuring it basically directly off of the first electrolytic. So what we will see here... if I bring this up, so there's 35 some odd volts. We're up to 80 here. The rectifier hasn't come up all the way yet, but I was getting about 200 measuring off of the actual center tap of the power transformer. Now, do we have a little bit there right now, but not much. Now, one thing I do have is I've got my crystalliner just offset connected to the antenna because I want to see if we can get a signal through. Previously, I was just getting static from moving the volume controller around. I want to see if the oscillator is running really, or if anything is actually happening. Just try and force a signal through, really. So, turn that up. Not sure if we got coming out there. So that should be... and that should be the first electrolytic. We're getting about 120 volts across that. I'll pop that off there and check it against here. Getting something like 90 volts there. Don't understand why it's that low. Once again, I'm getting some really obnoxious chittering over here. And I mean, I haven't recapped any of that yet, so that's very high pitched. Not sure if it even comes up on camera. Okay, so if I bring this up to 100 volts on the line, we're getting close to 200 volts on that first cap. And you can hear you can just barely hear we have, well, nothing really on the speaker. Alright, now we're at 110 volts on the line. 270 volts B plus is a little more like it. I'm getting some unusual. Yeah. Nothing really coming through. Okay. One thing I will say, it is reacting to me fiddling with the knob on the crystalliner here. So that's doing something. If I turn that down. Okay, so we are getting a signal through this, through the IF stages anyway. Now I've got the crystalliner set for 455. The book says this should be aligned at, what did it say, 445 originally? Hang on, let me shut that up. Yeah, 445 kilocycles. So I won't be able to use this unit for that. I'll have to use the RCA test oscillator. But it is good that we're getting a signal path through from the antenna all the way through the detector stage. That's a bonus. But the fact is, what if I set this to 370? Nothing. Okay, so we're not getting IF there. Let's set it to 1000 kilohertz. Sorry. And try tuning that in. Oop, I think I heard it there. Back it up a little bit. Okay, so we do have it there. Now let's see, let's go down to the opposite end of the band. Go to 600. I'm also assuming I'm tuning the AM, the normal broadcast band from 550 to 1600, or 1550. I might be on one of the higher bands, and it's... Yeah, not finding anything. Let me turn that up so it's obnoxious. No, I don't think we're in the right band. Let's try... 1400? Nothing? We might have just been getting a, let me turn that back up. I find it hard to believe that 1000 was in that range, but 1400 is not. 1500? Okay, so squat there. Oh, well, shoot. As it is, I don't have the remaining capacitors, the point ones I need on her. I don't have the rest of the parts I need to finish it right now, except for that one electrolytic. I can do that. So I think I'm going to place an order on Mauser, get the rest of the parts I need, because right now I haven't touched the oscillator section over here. The 6A7 mixer is tucked over in this side. So I think this is good enough for now. We've got B+. It's not on fire. That's a great start. We're getting signal through it, so that's fantastic. The IF stages are working, means none of the coils are really dead. And the detector and all that jazz is functioning. The only thing I couldn't quite figure out is 1,000 kilohertz it got, although I don't know. That doesn't necessarily mean the oscillator's working. So, yeah. I think that's good enough for now. We'll call this part 1, I suppose. Curious to see, did that get very warm? A little bit, not too bad. Yeah, I need to take care of the rest of the capacitors over here. I do at least have a 0.02, but I think this guy right here is another 0.1, and replacing some of those could help out. And then I'll wind up going through and checking all the resistors over here as well. I'm not sure if I'm really going to leave all the dog bones in place or not. I was just going to replace the ones that absolutely needed it, but as I go through, I figure I want this thing to work as long as it can for my grandmother, so I might just replace all of the dog bones with new carbon comp resistors, just for peace of mind. But that is in the next video, and I think that will do it for now. In the next one, we'll also take a look at the cabinet and look at getting it cleaned up a little bit, because it doesn't need much. The finish of the lacquer and everything is actually pretty good, and it should just be a matter of cleaning the gunk off the exterior and going over with a little bit of restore finish. There's a blemish on the top of the cabinet that I want to try and see if the restore finish will remove it. I had some luck with it on a Telefunken set that had some pretty bad watermarks. This one's got some alligatoring right dead center in the finish, and I think we should be able to get that to smooth out a little bit. But until then, thanks for watching, and I'll meet you back here next week.